Awesome. Thanks, TJ. Hey, well, thank you everyone for being here. Welcome to our virtual classroom. I think it's so interesting that this is kind of the new normal. This is pretty much how I spend my day, of just hanging out with my students in a Zoom room. And I have to say, all things considered, Zoom is pretty incredible. It's definitely supporting the weight of the world right now, and I'm very I'm happy that this technology is available to us. And that being said, I'm assuming since you have all made it here that you know Zoom well enough to have gotten this far, and since we're all approaching 3 months of shelter in place, I assume that most of you use Zoom pretty extensively. But just for the sake of being inclusive, I'll just kind of go over what we have going on here. For most of this session, I'll be sharing my screen with you. And you can choose to see me on the right-hand side, or you can click a grid view that gives you like a gallery view. And I personally like being able to see everyone's faces, so it doesn't feel like I'm sitting alone in my room talking to my computer, but to each their own. Along the bottom of the screen, there's an icon for the chat feature. And if you don't see a chat button, sometimes it can be in the More option. If you open that up, sometimes it lives in there depending on the size of your browser. So every morning in our classroom, we get started for the day by having everybody answer kind of a fun question. So everyone go ahead and open up the chat feature, and we're gonna get to know each other a little bit. So answer one or more of the questions here. Either what is your current or your most recent job? Share a TV show that you're into, loop us into what you have going on in your TV life. Or if you could keep a miniature animal as a pet, what would you choose? And there's no physical or emotional harm to the animal in this process because it's 100% hypothetical. Awesome. Great. Well, we're enjoying your answers. If you feel comfortable, I would love it if you could introduce yourself. No pressure, just if you're up for it. Please turn on your camera and unmute yourself for a minute and just say hi to everyone, and tell your name and tell us what brought you here today. And no judgment on any lack of haircuts or messy rooms in the background, because we're all in the same boat. So I'll go first. Hello, I'm Sarah, and I'm here to talk to you about coding and web development. Anyone else like to introduce themselves?
Sure. Hi guys, my name is Rachel. I am the associate instructor at Learn with Sarah, and I'm here to ask answer any questions that you might have in the chat.
My name is TJ. I'm the marketing manager here at Learn, and I'm here to hang out and help facilitate this event with Sarah.
And to be my shirt twinner.
Yep.
Hi, I'm Simon Prickett. I work for a company called Redis Labs. We make the open source Redis database that's pretty popular, and I run online training for it.
And Simon has come to speak in our classroom before.
I have also done that, yeah, and I need to figure out doing that online now. We've got things together a bit. We had our huge conference yesterday, and now we're past that. I have a ton of free time that I didn't have.
Awesome. It's super good to see you again.
Hello.
Hello, I'm Chi. I am part of Alpha 2020, and we're finishing up our internship, and I'm also an intern at Learn.
I'm Chantel. I most recently worked for a test prep company. I'm watching a show called Letterkenny on Hulu. It's about a tiny town in Canada. It's pretty funny. And if I could keep a tiny animal as a pet, it would probably be a tiny giraffe or a tiny hippo. And I am part of Learn Academy's Bravo 2020 cohort. So I am finishing up week 3 of my coding journey.
Awesome. All right. Well, thanks for introducing yourselves. If you guys have any questions at any point, just feel free to jump in. Odds are you're not the only one with that question, and I personally like it when we can just have conversations. I always learn a lot during that process. And just so you guys know, I have an additional monitor to my left, so if I'm looking over there, that's why. I feel like one of the weird sort of social structures of being on a Zoom is the idea of like somebody not looking directly at you can feel kind of odd, but just so you guys know, that's just my setup, so I can keep all of my various windows and screens open. And because I have a lot going on, I've asked Rachel to keep track of the chat, so feel free to ask questions in the chat if that's a better platform for you. And Rachel, ask you if like anything interesting comes up that I may miss in the chat, like please feel free to just jump in and ask questions so we can have a conversation about it. All right, well, hello. Let me introduce myself a little bit. My name is Sarah Proctor, and I'm an instructor at Learn Academy. Learn Academy is a web development bootcamp, and it was San Diego's, actually Southern California's first web development bootcamp. And Learn is a full-time 4-month intensive program, and we specialize in career transitioners. So we teach a full stack development, and we're going to talk about what full stack means here in just a minute. But our mission at Learn is to help build the tech community in San Diego. And hosting meetups like this is one of the ways that we offer our knowledge to just anyone who's interested in. This particular meetup came into existence about a year ago. So it's one that we've done a few times, and it's always really fun. The world of development and coding, it can be really intimidating. At least it was for me. And I really wanted to do a meetup that talks really plainly about what being a developer is in a way that's really approachable. And it doesn't make assumptions of knowledge, and it doesn't scare people away that may feel intimidated or a little unsure about what coding and what web development is. And I was actually, TJ and I were kind of brainstorming this idea, and we were kind of struggling to explain this concept at a meeting. And our boss, Rob, was like, oh, you mean you want to explain what the F coding is? And we totally laughed, but like the name stuck because that was absolutely what we wanted to do. So that's my goal. I want to explain and explore coding in a way that my mom will find understandable and interesting. And to be clear, this is not a diss on my mom. She's very smart and very tech savvy lady, but it's just the big picture goal of this meetup. So this is what we're doing here. And like much of the rest of the world, Learn transitioned into a virtual classroom it was in March. And so for 5 years, we taught in an in-person class. And to be honest, I was pretty nervous about going remote, about losing the connection and the energy that I get from my students. But I have to say it's going really well, like really amazingly well. My students are the best, and my team is super rad. And there's pros and cons to every situation, but I feel like we're surviving in a time that a lot of businesses are suffering. And I'm really heartbroken for the people whose jobs just disappeared. They just don't exist anymore. And it's really tragic. And I feel really lucky that we're able to transition, pretty seamlessly into a remote world at Learn. And I feel really lucky to be here because a few years ago, I was working in a restaurant, and that restaurant just closed. I mean, temporarily as far as I know, but all of my former coworkers are filling out unemployment and, worrying about what the next step looks like. And I worked at this really fancy French restaurant, and I was a server and a bartender and a bar manager, and I did ordering, and I built cocktail list and did wine pairings, and I did all this stuff. I washed dishes a couple of times because that's just, what needed to be done in the moment. And working in a restaurant allows you to make really great money, but I just did it for too long. And I ran out of new jobs to do and new things to learn. And it just became mind-numbingly dull. And there's all these built-in sort of systemic problems that no one had any interest in solving. And it drove me crazy to find a way to fix a problem. And everyone around me just go like, oh, well, that's just the way we do it. Or like, well, it's just always been like that. And it just like, it hurt my brain. And so I finally was like, I hit a wall, and I was like, I have to figure out what the next step looks like. And I studied psychology in college without any real direction. And I never felt like I had that thing, that like passion, or that thing I was super, super proud to be committing my time to. And so I literally sat down and made a list. What do I want my day to look like? What would make me feel good? What would keep my interest and allow me to explore new things? And what can I do where I can actually solve a problem and I can create and organize efficient systems? And I basically came up with programming. And a long story short, I found myself as a student at Learn Academy. And it's by far the best thing I've ever done, and here I am. So I really like doing these types of meetups, and I love teaching entry-level classes because I truly believe that if I can do it, you can do it. I had very little experience when I started coding, and it's hard. I won't sugarcoat how hard you have to work to be successful. Programming is really difficult. And furthermore, communication about programming is really difficult. You have to learn a whole new vocabulary and a whole new logical approach to problem solving. And working through ideas can be really hard. So you'll notice on my slides that we have a giant rubber duck, because there's this concept called rubber ducking, where you're basically talking out loud to, you know, yourself, to an inanimate object, or to a rubber duck that sits on your desk. And you're just trying to reframe the problem or to find holes in your logic. And so the giant rubber duck is kind of our mascot at Learn. And so coding is hard, but it's doable. And I want to make sure that personally that I'm doing my part to make the barrier to entrance for coding just as low as possible, because technology needs all of you. Technology needs everybody. It needs input from all the people who use it, which in 2020 is everybody. And there was a point in the recent past when technology was made by and used by a really small group of people. And the people who made technology were very, very smart, predominantly younger white men. And we can look back at them and thank them very much for their contribution, and we wouldn't be here without those very smart people. But that's not a thing anymore. It can't be a thing anymore. As a society, we have to open this field to everybody. It's too important not to. Because code is in our everyday lives. It's in our cars, it's in our medical devices, it's in our credit cards, it's in our entertainment, and of course our phones and all the apps that keep us functioning in the world. To apply for a job, to open a bank account, to apply for a line of credit, to rent an apartment, to buy household goods, to travel anywhere by plane, car, walking, whatever, you're probably going to use at least some small form of technology. And it's just, technology is not a luxury item anymore. It's critical to the function of our daily lives. And that can't be any more evident than it is right now. We all need to be staying home and staying isolated to stay safe. You know, and the model that's kind of floating around is stay apart together. But really how we stay together is through technology. And so I want everybody, I want anybody who's interested to help make technology better and to make it more inclusive. And so let's figure out what the F that means. So when we're talking about coding, I feel like there's a lot of just vagueness in that word. And when I first told people that I was going to learn coding, I got a lot of mixed responses. Some people thought I was learning medical coding, and some people asked me if I was learning binary or building computers. And really, it's really none of those things. While the scope of being a developer, that general term developer, is incredibly broad, it generally refers to creating software. And it's often referred to as software engineering. But most commonly, as a developer, you're creating web and mobile applications. And the general distinguisher between a web application and a web page is, does the user log in? Does the service save information about the user and allow the user to create content? So if I go to the website of a restaurant and I can see their menu and location and information about their business, that to me is a web page. But if I go to a website like Zoom, I can create an account and I can schedule meetings and my information is stored by Zoom. And that's a web application. And mobile applications are really basically the same concept with just a slight difference in the tools used and the deployment method, meaning that your content's available through an app store versus through a web browser. But learning to build static pages is super cool, and it's super useful because if you're a business and you don't have a website, you're not a business. But when we talk about being a web developer, really what we're talking about is building web applications. So things that you sign into that store your content. So why learn programming? In the early days of my cohort at Learn, we were asked why we wanted to pursue development. And this is kind of an aggregated list of what my cohort came up with. And I really like these things, so I kind of wanted to share them with you. One is that programming is challenging. You'll never know everything about development. It just isn't possible to know it all. I've worked with people who have been programming for 25 years or more, and they don't know it all. And they'll be the first to tell you that you're not going to know it all either. And that can feel incredibly overwhelming when you first start, but it's also kind of freeing. You can't know it all. It's impossible. So on the other side of that is that if you can reframe that, there's always more to learn. You're never going to run out of opportunities to learn something new. It's a lot of creative problem solving. There's no right answer in coding. If it works, then that's the right answer. There's better ways than others, sure. And there's definitely more elegant ways than others, but coding isn't black and white in the terms of right and wrong answers. And I really like that. I think that that expresses a lot of you get a lot of personal creativity in that respect. It's also it's a practical and it's a functional trade. And it's really neat to learn a skill that's so relevant. And to me, I was studying social sciences, and it was always about, I was learning theory and history and looking for trends and behaviors. And that's fascinating for sure. It definitely it expands your mind and your view of the world. But learning coding is just such a defined skill. It's such a tangible outcome that I think that it's a really powerful skill to have. And it's also the ability to create. And I see a lot of people drawn to code that come from artistic backgrounds, the type of people that just have ideas that they just need to get out of their head and to make real. And code allows you to do that. It allows you to express yourself through creation and that tangible moment of creating something that you can then see. Organizational skills is one of my personal favorites. You have to be very organized to be a successful developer. Your code base and your file structure can be huge, and it can be very confusing, as well as all of the tasks that you're managing. And it requires a lot of detail-oriented organization, which I particularly love. It's also a universal language. So even though coding languages often use English words, and everyone in the world uses the same coding language. And so everyone has the ability to communicate through code. And I think that's really beautiful. It's the connection across the world that draws us all together. And it also, it opens opportunities anywhere in the world, which is really great. Like, developers are needed everywhere, and they are needed right now. Zoom needs developers right now. They are actively hiring. And even there was teams that worked even remotely before the pandemic. And at Learn, we have a company we work really closely with that does remote development and does exclusively pair programming remotely, and has for years and years and years. So we were knocking on their door asking for advice on how to make our remote transition successful. And they had a lot of great tips because this isn't new to them. They've been working all over the country for years. And I think that that's a really amazing benefit that a lot of people are looking for in a job. It's also really, it's really beautiful. Coding is artistic, and you can make beautiful ththings with code. And there's a lot of digital art mediums that are amazing, but the code itself, the actual code that you write, can also be really, really beautiful. You'll just every once in a while run across a code snippet, and it's just like, holy smokes, like that just solves the problem in such an elegant way. It just like, the code itself becomes very, very beautiful, an art form in itself. And I think it's also really important to understand the technology that we use every day. Like we need our phones to function. A few months ago when I was going to the office every day, my phone was the key to the front door. And now being remote, I definitely need technology to go to work. Slack went down for like a half an hour the other day, and I did not know what to do with myself. Like we lost communication with the team. I didn't know how to connect with my students. I was trying to tell them something and I didn't know what to do. And so we're very reliant on that technology. And so knowing how those things work is super important. And I found this quote recently by Carl Sagan that I thought was really amazing. And it's been true when he wrote this in 30, 40 years ago. And it's still true now, that most people use technology and don't know what it is actually doing. And so learning to code is like peeking behind that curtain. So let's talk about the programming languages themselves. So programming languages are a lot like any other language. Developers use language written by other people to create new things. just like we use the English language and established words and established grammar to express our own ideas by creating new and unique combinations. And so programming languages have vocabulary, and they have sentence structure, and they have punctuation. We just call it syntax. But all of those things are still wrapped up inside of our programming languages. Because ultimately the goal of code is communication. One, we have to communicate to the computer the actions that we want to perform. Computers are inflexible machines. They are really, really good at doing one thing over and over and over again. Computers are not good at nuance or implication or getting the gist of what you mean or making a peanut butter and jelly sandwich. But the second part, the most important aspect of communication, is that as a developer, you have to communicate what your code is doing, both to other developers and even to future you. Because no one is a worse developer than you 6 months ago. And if you create something fantastic, but no one can understand its intent, then no one's gonna spend time fixing it when inevitably it needs updates. And so no code that is written poorly is going to be kept no matter how fabulous it is in that moment. So in the broadest, most oversimplified terms, coding can be broken down into two main components, the front end and the back end. And the front end, sometimes we refer to as client-side development. It's basically all the stuff that the user sees and interacts with on a web application. The front end is both the UI, which stands for the user interface, and the UX, or the user experience. And in large companies, there'll be teams of people in charge of each of these aspects. But the UI is the visual aspect of the page. Is the app nice to look at? Is it pleasing to the eye? Is it on brand for the business? So I kind of think of the UI as the art major of development. And then the UX is your app easy and intuitive? Can your user navigate the application? And can your user easily get to the desired result? And is the user able to access the key features that your developers have created? And so I kind of think of the UX as the like the sociology major of development. And I remember a few years ago when the Lyft app first implemented a feature where you could see all of the little cars and icons moving on the map, and it was super, super cool. But like during the early stages of development, there was the process and the series of entering info and confirming, and eventually takes you to confirm with your driver, and this map would pop up and you would see all of the cars and moving around. But the problem was that there was one more button you had to click to confirm your pickup. But from a user's perspective, like the button was fairly small and the map was very visually stimulating. And so I had taught my parents how to use Lyft while they were visiting me, and they decided to flex their new skills and get a ride home from the airport. And so they're standing at the airport and they've put all this stuff in and they're watching the cars drive around on the app, and they can't figure out why no one is stopping to pick them up. And so my dad calls me, he's all frustrated, and he's like, the app is broken, it's not working. And while I found this to be a hilarious moment of old person syndrome, it's a problem for Lyft, because that one button defines whether you're a customer or not a customer. And that one button is ultimately making Lyft money or not. And the baby boomer generation is a huge market for rideshare companies. And so the importance of creating good user experience is necessary for everyone, no matter what your familiarity of technology is. And so there's lots of front-end technologies, but the three that are pretty much on every web page in existence are HTML, CSS, and JavaScript. And those are basically the main building blocks for development. And those are the ones that we're going to talk about a little bit more in just a moment. So the second main component of coding languages in general is the backend, or server-side development. And that's all the code that's under the hood, so to speak. So it's the code that allows web applications to save information and render information when requested by the user. And so the backend is all storage content and data structures. It's the engineering major of development. And just like the front end, there's many, many languages that can be used for backend development. At Learn, we teach Ruby on Rails, which is a framework that's called Rails, written in a language called Ruby. But other popular backend languages are Python. It's really popular for data science right now. PHP is the backend for WordPress, which is a really popular way to build applications. Node.js, .NET, Java is still a pretty popular backend language. And Java, interestingly, I think this is so funny, it should not be confused with JavaScript, which is our front-end language. And back in 1995, the guy who invented JavaScript purposely named it in a confusing way because Java was really popular at the time, and he was sort of hoping to steal a little bit of Java's thunder. And spoiler alert, it worked. JavaScript is now an incredibly popular language. So backend development is, it's basically code that receives requests from the front end and sends information back. And so to kind of explore that a little bit more, let's talk about the internet. So this is an incredibly overly simplified explanation. The internet is the largest machine on Earth. It's kind of like that colony of quaking aspens that all have like interconnected roots. And in the most fundamental way, the internet is just a series of tubes that connects servers all over the world. And really a server is just a computer with all of the user aspects stripped away. So your computer that you're on right now is a server. Developers use their local machines as servers during the development process of an application to run our code. We'll run it locally. And all the content for websites in the world is stored somewhere on a server. And Amazon actually owns like a ton of server farms all over the world. A lot of the internet is hosted on Amazon servers. And so there's server farms are just basically warehouses that are in the middle of nowhere where land is cheap and probably in like a cooler climate. And there's just basically stacks and stacks of computers with all of that user stuff gone. And so when a website is hosted, meaning that you can find it on the internet with a URL, that content is stored on a server, or more likely many servers. And the user makes requests for that information. And so the request travels along these tubes, and the location to the server gets the information and comes back. And I love this picture. I think it's so amazing. It shows all of the fiber optic cables that run along the ocean floor. And I just think that's incredible to even think about. And just for fun, there's this little robot guy that I love that lays all of the cables on the ocean floor. And so it's not really important to this topic. I just think it's really neat that this little guy's job is to just go down and lay down the cables and runs into sharks and stuff. It's great. Anyway, so the long and the short of the internet from a developer's point of view is that it's a series of requests and responses. So when you navigate to a web page within an application or enter information on a form or post a picture or click on a show more link, anything that gives you a new view is a new request response cycle. And development is creating code that makes this successful cycles. The request response cycles, they follow HTTP, which is Hypertext Transfer Protocol. And HTTP is just a collection of sort of agreed upon rules that make this cycle consistent and successful. And so there's four main parts of this HTTP protocol that I'm just gonna briefly go over. There's the request, which consists of the location and then the action. And the response, which consists of the status code and the payload. So we'll start with the request. So the request response cycle, it starts when you hit enter on a URL. So a URL is a uniform resource locator, and don't memorize that because nobody does, but URLs are all corresponding to IP addresses. And an IP address is just the physical location of that server that's storing information that you want to see. So there's our first item is the location, right? So an IP address is a set of 4 numbers that are all divided by periods. And each of the 4 numbers is between 0 and 255. And because 255 is the largest number that can be represented by 1 bit. And a bit is just a unit of storage that can hold up to 8 binary digits. So meaning any combination of up to 8 ones and zeros will represent the numbers between 0 and 255. And that's just how that worked out. So development is basically translating things from human readable information to computer readable information. And this is a perfect example of that, right? So URLs are for humans. Google.com is for humans. The IP address is for computers, because most of us don't process information in octets of base 10 representations of base 2 numbers. So at least I don't. But that's what an IP address is. So we process that information as a URL. So the first challenge we have in our request response cycle is that we have to map that URL to an IP address. And there's a lot further complexity into that process that I'm just going to very much skim over, but it does take a lot of work from an energy and a processing standpoint to look up an IP address. And so I mentioned that developers often, use their own computers as a server, and the IP address of your local server or your home server is 127.0.0.1. And that is the URL that maps to the IP address that is localhost 3000. So when we code on our home IP address. So along with the location, the second thing that makes up the request is the action. And the action describes the type of request that we're making. And developers have to be to specify basically a type of request in their code. And there's a best practice that developers follow called a REST, or a RESTful architecture pattern, that I just have a brief diagram here. But this basically covers the actions that you would want to achieve with your code. So if you want to list content or get request, if you want to create new content or a post request, editing content would be put, and then of course deleting content. And our RESTful architecture kind of lays out how you should perform, how your program should set up this URL in order to achieve that. And so this is our request. And so our request finds the server, and the server responds. And so that's the next thing on our list is response codes. And response codes are just a tool that developers use to provide information about the request response cycle. And every request gets a response, but sometimes those responses are successes and sometimes they're errors. And by giving those a code, developers can tell the application what to do. So if the response code says like, yep, you're all good, then you can go ahead and load the page. And if not, then let's tell our user that there's a problem rather than just like leaving them on a blank page or like leaving them on a broken application. And so one of the most well-known response codes is a 404, information not found. I feel like we see that one pretty often. And it's just kind of a generic catch-all for like something about your request went wrong. And there's an error coming from the client side in the request response cycle. And if that happens, and it does, developers can code pages into their application that will display a cute error message and possibly give instructions for the user on how to fix the problem. And that is a good user experience. So there's this website that I'm obsessed with that has all cat pictures that represent all of the status codes. It's awesome and I love it. And we don't really need to go into the function of each code. That's not super important, but I just really want us to look at cat pictures because they're funny. So we're going to go through a couple. So just the 100 level responses. I think there's really only like these two, but they're just informational, but cat pictures. The 200s are good, right? 200s are what we want. 200s mean like, yep, information's working, coming back. The 300s are redirects. So the thing that you're looking for isn't here anymore, or the request was sent to the wrong place. So 400s, right, like the 404, it's a client-side error. So something about that request was wrong. And there's lots and lots of 400 status codes because it's a pretty common mistake. And then 500s are just a server-side error, so the opposite of that. So there's an error on the other side of our cycle. So the request got there, but for whatever reason, the server isn't able to provide what you're looking for. But I just wanted to tell a really quick story about the 418. So that's one of the client-side errors. But the name of this code, this 418, is called "I'm a teapot," and it was created as an April Fool's Day joke in 1998. And so the joke was that, you know, as much as we all love HTTP, there should really be an HTCPCP or hypertext coffee pot control protocol. And so this was set up for the very specific time that a coffee pot needs to transmit documents over the internet for controlling, monitoring, or diagnosing coffee pots. And so it continues that in any attempt to brew coffee with a teapot should result in a 418 error code, I'm a teapot. So the error code description, which I think is hilarious. So it is, the resulting entity body may be short and stout. So, so this joke kind of lingered for like years as this weird like internet Easter egg. But a few years ago, someone who I can only assume just kind of needs a hug, just decided wanted to get rid of 418 because they're like, it doesn't serve a practical purpose and it's taking up space where you could have another error code. But some people had a very different opinion about that. And so there was a 15-year-old in the UK who mounted a crusade to save the 418, and then Reddit got a hold of it and it just blew up. And so we have successfully, as a development society, saved the 418 status code. So the piece of internet history has been preserved. Anyway, let's move on. So we've done our request, we've done our response. So what we get back is the payload. So the payload of hypertext transfer protocol is hypertext markup language, or HTML. And HTML is it's the foundation of the internet. It's everything that you see on a web page or in a mobile app. Everything is delivered inside of HTML. And often, I mean, this payload can be huge. So imagine the size of like a Netflix payload. And in order for that payload to travel as quickly as possible, it's broken up into tiny little packets. And the packets are like, I don't know, 1,000 to 1,500 bytes or so. And they're still going through the same cycle, and they may even go and take different paths depending on what the fastest path may be. But they will all the requests will go out, and all of the various pieces will disassemble and then arrive and reassemble in their appropriate places, like the kid from Charlie and the Chocolate Factory that travels through the TV and reassembles. And so when it's all said and done, this request and response cycle and all of its intricacies, and no matter how far the server is from your computer, all of this happens in a fraction of a second. And if it doesn't happen in a fraction of a second, your users will leave you. And so speed is one of the, it's considered one of the unsexy pillars of development. And the other two, just in case you're interested, is the other two is security and accessibility. So those are the three unsexy pillars of web development. But users notice. We visually notice if a page takes more than a second to load. And we will be distracted if it lasts longer than that. And more than half of the users won't wait 3 seconds for a page to load. They'll just leave. So making sure your website is fast, and it comes down to, I mean, first of all, the amazing infrastructure that allows our little robot friend to put fiber optic cables along the ocean floor. But it's also it's also down to the developers to write clean and really efficient code. So. All right. So one of the ways that that developers interact with their computer is through terminal. It's one of the most important tools. It's a computer's command line, and this allows developers to make text-based commands to the computer. And so in the early days of computer, this was basically all there was. So the reason personal computers became a thing was because of the graphical user interface, or as we call it, a GUI, a GUI. And GUIs give us the ability to view nested file structures in a windowed format, or to point and click, and that's what made Bill Gates just a boatload of money. And PCs would never have become a thing if we didn't have like the fun displays with clickable icons and screensavers with flying toasters. And behind the click is still just a text-based command. It's just wrapped up in this GUI, and so it's still a communication between a human and a computer. So in Terminal, developers kind of use this in order to bypass the GUI and to directly interact with the computer. So I just wanted to play around with this for a minute. Sorry, I make you dizzy here. So we can actually, like I said, this is the place where we would set up in order to run our local development environment, but we can actually send out a teeny tiny request and response cycle to a website in our terminal. So we can kind of just like poke at a website and see what happens. So it's called a ping, and it just sends out the smallest response and request and is just looking for the tiniest response. So let's ping Learn Academy and see how that website's doing. And so it just sends out routine, like a regularly interval little requests. And then it logs information about that response. And so that the time for each of that little transaction, it occurs in milliseconds, which is pretty cool. So it tells you, it sends out those pings, looks for the response, and then just tells you information. So what was the minimum? What was the maximum average time? And then the average and the standard deviation of each. So, you know, just some good, clean fun. All right, so let's go back into HTML. So hypertext markup language, it's the words on the page. If web development were a human body, hypertext markup language is the skeleton that holds up the structure of the web page. And if we go back to like our language analogy of thinking of these as you know, human spoken languages, the HTML is kind of the nouns of our language. And HTML really came about in conjunction with HTTP, the Hypertext Transfer Protocol. And because hypertext is a part of both of those acronyms, it's because they're connected. And in 1989, this incredibly smart human being named Tim Berners-Lee was working as a physicist at CERN. And he developed this idea of being able to share documents via hypertext. And so the idea was to introduce a system that would sort of unify and standardize the internet. And so his team came up with this crazy idea, and they called it the World Wide Web. And HTML was the first language that would work on all computers, you know, regardless of how they were made and what internet you were running on. As long as you were connected to the internet, you could access HTTP, and that's incredibly powerful. I found this this website for the other day. I was looking for something completely different, but I found this page, and this is just basically unadulterated HTML. And this page was created, and it's super tiny on your screen, I imagine, but it says it was created in 2002 and updated in 2003, and so almost 20 years ago, which is crazy. But this worked, right? I mean, like, this was sufficient exchange of information. And the other thing to note, that I found this this website, it's connected to, it's a college in Vermont, so the URL is vermont.edu, and the original widespread application of HTML and HTTP was really like this amazing ability to access research papers and materials and books. And if you were, you know, you can imagine if you were doing research in California and you needed a book from a library in Michigan and a thesis paper that was in a library in Colorado, that you would be calling up the research librarian and requesting this information to be, like, you know, photocopied or mailed to you or something. And so the idea of this huge, like, massive documents that are all over the world that could be available online was just incredibly appealing and life-changing, really. And so the educational community really embraced HTML. And a lot of the early structure was created in order to provide formatting for scientific papers and for books. And we still use a lot of that same formatting today. And so when we're talking about HTML formatting, really what we're talking about is HTML tags. And a tag is just, it's the basic unit of HTML. And so tags give the computer information on how to display content. And generally speaking, there's two different types of tags. So some tags, like headers or buttons, give specific instructions on how the content should be displayed. They let the computer know what this information should look like when it's being rendered in the browser. And then there's others that are just generic containers. And so div tags, like I have here, are sort of our favorite generic containers. And all code needs to be stored in something. And so a div is kind of like that, like, it's kind of like one of those like plastic storage totes that's just empty and ready for your code. And all tags open and all tags close. They open with the 2 carets and then close with the same one with a backslash or a slash in between. And everything inside of those tags is the inner HTML. And so what's inside is all of the stuff that shows up on the page. And so tags they're just instructions. They're just telling the computer how to process information. And so we can actually pass in more information to a tag. And so when we do that, we call them attributes. And we can pack in as many attributes into our tag, within reason, as long as our code is still communicating properly, because that's ultimately the goal of code, is to communicate. And so our div tag is just a sort of nameless plastic container, but we can give it an ID attribute that allows us to sort of label this particular div. And then we can reference that div by its ID somewhere else in our program. And this was an example I just came across. It was one of a portfolio of one of my students who's currently off in her internship, but this is just what her code looks like when it's just rendered in the browser, like behind the scenes. And so I'll show you in just a minute like how I found this particular view, but I liked this example because it just kind of shows like it's just a series of tags with some inner HTML really when it comes down to it. And of course a lot more work put into it besides that, but really this is what the browser is reading. So the other language that every developer needs to know is CSS. And CSS stands for Cascading Style Sheets. And it's all the code that makes the page looks good. And so without CSS, every page looks like this one, like it fell out of the 90s. So if any of you are here to remember, old enough to remember MySpace, you could jazz up your MySpace page with CSS. And so it's kind of the skin that covers the skeleton of our body analogy. And for our language analogy, it's kind of the adjectives of our programming language. But adjectives need something to describe. And so CSS needs HTML in order to create styling. And so CSS will target either HTML tags or those attributes that we've applied to them, and then applies modifiers to them. So I created this just silly little page this afternoon with just very basic HTML. There's nothing fancy going on here at all. But if I find my page, if I add in my styling, that's not the page I want. Sorry, 1 second. Oh, I lost my page. What's the fun of a live demo if you don't lose your stuff halfway through? All right, there we go. So I'm just adding in my style sheet. And now if I refresh it, this is the same base code, but I just added in a couple of styles, and you can see that clearly it just looks very visually different. But this took very little effort in order to sort of jazz up the page and, keep it from looking like our, fell out of the 90s type of page. So with my quick little example here, just because I wanted to code up something super, super fast, I used lorem ipsum. And so that was my dummy or my filler text. And it's sort of a tradition. It's kind of like fake Latin, but it has a really interesting history because it originates back in into like the 1500s with the Gutenberg printing press. And so it was this collection of test characters to make sure that the printing press was working properly. And so it's survived over time. It's still a thing, and it's made its way into this like modern technology world. And so, you know, when you're developing and you need to design the look of something or just have content on your page, but you haven't really made the copy yet, or you need that placeholder, you can use lorem ipsum. And of course, because, you know, the internet, there's many ipsums out there. And so I just wanted to share a couple that I really think are hilarious. So there's hipster ipsum, Snoop Dogg ipsum, and then there's doggo and cat ipsum, of course, and pirate ipsum. But it's just the idea of like being able to create content that just in case you forget, it's not going to cause any kind of problems. There's sort of a famous story from our bosses who run a web development consultancy that somebody they were working with was waiting for that copy to come back from some other department, and they were creating a page that they needed to write some kind of security message, and they needed to style it, and they just put in their own filler text in the meantime. But rather than using lorem ipsum, they chose to write like, oh, this is where we're gonna steal all your shit, and forgot about it, and it went live. And that company lost a lot of money during that weekend before somebody caught it, and that person was very much in trouble. So lorem ipsum is a very safe way to put filler text on your page, and also can be really fun because who doesn't want to read Snoop ipsum? I mean, that's just a good time. So I wanted to talk really quickly about developer tools, because this is super cool. So inside of just our regular Google Chrome, we can see so if you right click and inspect the page, then you'll bring up this whole hidden world of technology. And in here, we can actually see what the page, all the HTML and all of the stylings look like on the page. So I'm gonna move this down. And I just think this is really incredible because this is all like just available to anybody who wants to look for it. And I was reading just a random article on Code Academy the other day, and for whatever reason I was in their developer tools just like looking at something, inspecting that page, and you can look and see what all of the content of the page is, but I clicked over to this other console tab, and the console actually allows you to run JavaScript in the browser if you were so inclined to do so. But I thought this was really fascinating because inside here they actually have an ad that they're looking for developers, and they've targeted it at a place where somebody who's probably a developer would look. And I just think that that is like incredibly brilliant advertising. So anyway, I thought that was very clever. But this is all like available, and when you're first kind of learning code and just getting familiar with what's going on a web page, I think it's really interesting in just trying to kind of read through this and see what's happening and seeing what all of these things are doing. Because even though we just see a Google page that looks fairly plain to us, there's actually a ton of stuff laying behind the scenes. I mean, it is Google after all. So that leads us to JavaScript. And JavaScript is our power language. It's what provides interaction with the user. And so if you click a button, or you see an alert pop up, or you watch pictures that auto scroll on your screen, that's all JavaScript. And JavaScript is, it's the muscle to our skeleton. And so it still needs that skeleton. It still needs that HTML, just like CSS still needs that HTML. But in our language analogy, JavaScript is like the verbs, it's the action. And JavaScript allows us to perform logic. And so far, the other two languages are just markup. It's just static pages. And JavaScript is very different from that in that it allows us to manipulate data. So we can store information and ask the computer to run mini programs that will evaluate that information and perform actions based on the outcome. And because JavaScript manipulates data, it's very particular about the data that it processes. And so JavaScript has categories of information that it'll work with. And these are called data types. And there's roughly 7 categories of data types, and I won't nitpick the specific breakdown, but the ones that we should all be familiar with are strings, numbers, and Boolean values. And strings are just characters that are stored inside of quotation marks. And strings have particular properties like length or the ability to identify a location of a character within the context of the string. And numbers are just exactly what you think they are. Numbers allow us to perform mathematical functions. They allow us to compare values. Boolean operators are true and false. They're used to perform logical comparisons. So for example, like, is 6 greater than 3 would return a Boolean value. And in JavaScript, we can store information by creating variables. So just like in math class where x equals 6, and then anytime you reference x, really what you're referencing is the value that's assigned to x. And developers do the same thing. And so anything saved into a variable needs to be one of those data types. And so I wanted to show you really fast. This was a project that my students are currently working on. They are in week 3 of the cohort right now. And so they are working in a JavaScript library called React. And so they are creating tic-tac-toe games. And while originally, like, from all of that boiled down, ultimately what's being rendered on the browser in React is HTML, just like anything else. But behind it is this big library that brings a lot of power. React was actually created by Facebook. And so it is very scalable. It's designed to be complex and to manage large scale applications. And so inside of this, we run JavaScript code. It's JavaScript code that's a bit more complicated than just the basic saving of variables, but it all works from the same fundamentals. And so it allows our students to make applications. And today we made a tic-tac-toe application. And so it may seem very, basic, like, okay, sure, like, it's fun. But really what goes behind the scenes and creating the logic behind this and being able to make these decisions and make these outcomes and have it be styled and have it look pretty and have it perform the way you expect, it's much more complicated than you may originally think. And so it goes back to that appreciation of all of the work that developers do in order to make this technologies available to us. Because even something like once I've won a game that I shouldn't be able to click again and change any squares. Once the game ends, I shouldn't be able to continue on and click a spot. I should have to restart. And even all of that has to be built into the logic of our game board. And you have to explain to a computer that's an inflexible machine that doesn't understand the role of a gameplay and doesn't know how to take turns. You have to explain all of that in a logical progression in order to make this application work. And on top of that, we're using a particularly large scale framework where we're writing JavaScript. So I think it's pretty amazing. They all did a really great job of solving this problem and writing the complexities of this code in order to create this application. So there's a couple of sources that I had from my talk today. You can look up cat codes, and you should, because they're awesome. And you can also, save the 418, go keep internet history alive. CodePen is also a really cool place to be able to play around with code, as well as just opening up your Chrome editor and goofing around inside of the dev tools that are available to you just on everyone's computer, which I just think is so amazing. There's a really cool website as well called Zen Garden that it's devoted entirely to styling. And it's super cool because they create this base content, this base HTML, and then they just say like, great, like take this and add styling to it. And the only thing that people are allowed to change is just the stylings. And then they'll feature all of these amazing, beautiful pages that all look so different from each other. And the only thing that's different is the styles that are applied to that HTML. And I just think it's really incredible. Well, I'd love to open the floor up to any questions that anyone has, as well as offer you the opportunity to join us for Jumpstart, if you are so inclined. We do a weekend programming kind of mini boot camp that Rachel teaches and that I help out as well. And our next Jumpstart weekend is happening mid-June. So it's 3 nights, and we explore all these technologies that we were talking about. So we talk about HTML, we talk about CSS, and we talk about JavaScript. And at the end of the weekend, we create a little game that we actually deploy. So it's like you have a live link, it's hosted on a server somewhere. Your friends and family can make a request response cycle in order to see your web application. And it's a really good time. So there's a link here that I will add to the chat if anyone is interested.
Oh, all right, I just did that
Got
for
it. Awesome, thank you, TJ.
you. I also allowed, anybody can unmute themselves if they have a question
Yeah, please.
or ask in the chat.
For sure. And thanks to my students for hanging out.
Cool. And then we're also recording this presentation, so this will go up on our YouTube channel here in the next day or so. And I'll also have Sarah's presentation to go along with that too.
Great.
Cool. So
Simon, what are you, sorry, go ahead, TJ.
No, go ahead.
I was just gonna ask Simon what he's been, how working from home has been, if he's still here. Oh, all right. Never mind. Cool.
Let's see. Somebody had one question. Simon
sorry.
said he can't unmute. I'll unmute him. Oh, it's not letting him.
Hey, there we go.
Oh, okay. Hey, how's it going?
All right. I think I work from home normally, but working from home is very different because working from home also means the coffee shop down the street and the apartment common room area and all sorts of other things that it doesn't mean anymore. That's been really strange. And yesterday we ran our company's major conference, and we did it in a virtual environment. So I think of something like Minecraft, where you stand in front of a stage and you watch a video on YouTube. So yesterday I had this weird experience of like virtual me that was wandering around as staff answering questions, watching real me from 3 weeks ago sat on the other side of my living room on a recorded session on YouTube, and then going into a live session on YouTube streaming to answer people's questions about that recorded session. So all of this weirdness is new.
Yeah, we've been exploring a lot of different ways to create interaction in virtual meetups. The idea of like being able to mingle is sort of, it's been lost. And I've looked at a couple of platforms that do things like that. It's so fascinating.
Yeah. I think also tools like Trello, where you don't have to be on a Zoom call and you can all see things update in real time, or like GitHub does a lot of that.
Yeah.
Yeah, you can just watch the website.
For sure. Cool. Thanks for Miguel and Trip. Thanks for coming back and joining us. Appreciate you guys stopping in.
I think we had one question.
Oh, I'm sorry. I should be looking at the chat. I'm sorry. I'm totally not.
Why is it called Boolean?
Thanks, Rachel. I actually have a really good spiel for this, but I should have looked at my notes before. But Boolean is a mathematician from like the 1650s. I'm pulling from my memory, not from my notes, that created this whole subset of algebra that was based entirely in this value where, or this, from the construction of the idea that something is either true or false. And that also stems directly into the idea of binary. And so when binary was invented, the idea of this electrical circuit that is either connected or not stemmed from this idea of the mathematician who created this subset of algebra of true and false. Oh, thank you, Chantel. 18. Ooh, off a couple centuries. No big deal. 1854. And so that directly led to the idea of writing in binary and connecting those electrical circuits. And so that area of math is what all of our computers operate on, because ultimately when you boil this down, when you boil all of the code to lower and lower and lower levels, you get down to a machine code where it's just sending a signal that's either on or it's off. It's either completing a circuit or it's not. And so when we get down to the root of it, it's a Boolean value that allows this all to happen, which is pretty incredible. Thanks, Rachel.
Any other last minute questions here before we wrap up tonight? We got a few more minutes left until 7.
Yeah, I mean, I'm open to
I put this in the chat, but I have a story for you at some point about underwater Ethernet, or not Ethernet, fiber
Yeah.
optic cables.
Awesome. I remember like originally looking up, you know, just the idea, like, because like when we all work from Wi-Fi, I think there's this assumption that like, you know, that things don't need to be physically connected anymore. And really it's just that, you know, just because your machine isn't connected, there is a connection that's happening somewhere very close to you really at all times, or through, you know, satellite or whatever. But the idea that we're still all connected by wires, and that these servers have to live somewhere. There's still this physical place where our code is being stored, and we can't escape from that, even though it seems very ethereal. And so I like that idea. And then when I found the little robot guy, I was just hooked. I was like, that's it. He's my best friend. I love him. Put googly eyes on him and keep him for my own.
Yeah, there's some article somewhere, I think it might be Atlas Obscura, where somebody systematically visited all the points where the cables break land, and there's obviously like a secure thing where it comes out the water and disappears. And that was kind of fascinating.
Oh, that's super interesting.
I used to live in New Zealand, and you definitely knew when you were accessing something that was like really East Coast USA or somewhere, because it's a cable.
I also really love like a couple years ago, well, a few years ago now, like all of a sudden the URL extension .io became really popular, and I totally just made the assumption that it was all these new like tech startups that were buying up this like type of domain, and so I just assumed it was like something cool and techie that I didn't know about. And when I was researching a little bit more about domain names, so every country in the world has its own specific domain that's sort of given to it. So, you know, you guys will see like .uk stuff that will pop up, and it just means that was a domain name that was given to UK to do what they want with it. And so the .io is the domain name for like the British East Indian Ocean territories or something. And so they were like, hey, yeah, we don't care about this domain at all. We don't want it for our country or our territory. And so they just sold it. And so they, all of a sudden, these domains that were not available before became super, super cheap. And a bunch of tech startups started buying them. And so it's actually the domain of this random island in the middle of the, I don't know, wherever, that is representing the IO, and not, you know, like I thought, something cool and techie.